Hi, everybody. I'm Anthony Shaw, and I'm going to be talking about observing AI applications from dev to production with .NET Aspire. And in this talk, I want to cover off a few things. So I said observing applications. So what is observability? We're going to talk about open telemetry as the standard for our observability strategy. Considerations for observability in production. So I'm going to show you two demos. One is a production application and one is a dev environment and a dev application. It's the same code base, but we've just got different ways of monitoring the application. I'm going to talk specifically about observing AI applications and what makes them a bit different and what ways you can use to observe AI applications. And then I've also got a list of resources and additional links and stuff for you to check out. So before we get cracked into that, my name's Anthony Shaw. I work in the cloud advocacy team at Microsoft. I'm actually focused on Python. So whilst I'm speaking at the .NET conference, my expertise is in Python, but I do a lot of work with .NET as well. And I've been using the .NET Aspire dashboard in particular for observability in a series of Python applications and just love using it. So I've basically applied that same approach from Python to the .NET stack. And I've used the same techniques in .NET and Python. So we're kind of building applications in both environments, but just love the Aspire dashboard and what it kind of brings to telemetry. So first things first, what is observability? You've probably heard terms like logging and monitoring before, but observability is kind of a bit of a convoluted way of saying that you're trying to understand an application better by looking at its outputs and trying to instrument its inner workings. So with there's different ways of doing it. So why would you have observable applications in the first place? If you just have logging, the reliability of logging depends a lot on what you're logging. And when things go wrong in an application, it's difficult to know beforehand what you should have been logging or what you should have been capturing. So the idea with observability is that you instrument an application by trying to capture as much information as possible so that when things do go wrong in whatever form, you can kind of wind back the clock and look to see what was happening at that time. So for example, if you got reports from a user that, oh, last Tuesday, the application was running really slowly and we got this error. And then you ask them, okay, what was the error? And they go, I don't know, I didn't capture it. Like, how would you kind of wind back the clock to understand if there was a crash or an unhandled exception, or even just it running slowly or differently? What kind of factors contributed towards that application having that behavior? So this is kind of the benefit of hindsight. Each time you have an issue with an application, you might add more logs, more information to it. But the idea with observability is that you use instrumentation to capture metrics, logs, and traces in your application, kind of to see everything that's going on. So that's kind of one thing. Another is that you try and simplify the complexity of the app. So I'll talk about traces in this talk, but if you just log absolutely everything, you've got reams and reams of data, of text, of information. And when things do go wrong, you've got to sift through that. And I've definitely been in scenarios in the past where, we've had a fault with an application or a bug that we're trying to track down, and you're just looking at thousands and thousands of log records, trying to figure out which one contributed to the crash. Or which one contributed to the specific issue that we're trying to track down. So with observability, the idea is that you kind of capture a session or a trace from when the user initiated it to the back end. And I'll show you some ways of visualizing that as well. This is not just about having lots of data captured in the database. It's actually about using tools and UIs to visualize what's happening in the application. And then we can use that to capture trends as well. It's not always as clean cut as a user reporting a problem. You might actually see performance degradation over time. So, for example, you may not have noticed, but your application started running 20% slower when you made a new change or a new deployment. So observability is a good way of capturing trends and data because you're instrumenting the application in the back end and all the different components, and you're capturing that information. You can see historically how things have worked, and I'll show you what that looks like in the UI. So OpenTelemetry is the standard I want to talk about today when we talk about observability. It's not the only option. There are other tools, there are other standards. OpenTelemetry actually replaced a number of other standards. So there were things like OpenCensus, was probably the main one. It was a combination of that and some other projects. It's backed by the CNCF now as well. So OpenTelemetry is a modern standard. It's for observability of any application. So C++, C Sharp, Go, Java, JavaScript, Python, Rust, as well as things which are baked in. You can trace end to end from the front end to the back end. So this is super important. So the app that I'll show you has like a JavaScript front end. It's some JavaScript components. And then it has like an ASP.NET backend. It's got a serverless component to it. It's got like a lot of different services working together. But because you've got a standard that's actually built to be agnostic of the technology, then you can trace things from start to finish. OpenTelemetry has also got a massive ecosystem of libraries for instrumenting other tools and third-party packages across all those languages I spoke about. You can also kind of plug and play where you want to put the data. So I'll show you the Aspire dashboard and also application insights, but you can export to other platforms as well. Like I mentioned, it's governed by the CNCF, the Cloud Native Computing Foundation. It's an open source platform, and it's an open standard. And it also comes with a protocol, an open protocol called OTLP, which is an open spec for communicating between where the data is collected and the software. So it's basically one massive big open spec that looks at your application. And then the first thing you would do with OpenTelemetry is you'd start putting instrumentation on the app. There's different ways of doing that. If you're using frameworks in your application, like ASP.NET, for example, you would use the ASP.NET instrumentation library. That is the package that you would download and configure in your application. And it would automatically set up instrumentation for things like incoming web requests, set a trace on the users. It would look at the logs by default. So often with OpenTelemetry, you can just download a package from NuGet, add it to your application, and the instrumentation will come out of the box. You can write your own custom instrumentation as well. So if you want to capture attributes for the app or anything specific, you can use the OpenTelemetry SDK for C# to build that in. You then have basically three categories: traces, metrics, and logs. And I'll show you all three of these and how they kind of work together. But your application runs, you put instrumentation on top of that, and that emits traces, which are like detailed events, basically capturing what's happening in the application, which are formed in like a tree structure. So if you imagine a user clicks a button on the website, that then starts a trace or a span, and that might then kick off lots of different things. Like it might send an API request. That API request might run a database query, for example. So like that trace goes end to end from the user initiated action all the way down to like the backend queries or reading and writing files. So that's the traces. Metrics are more sort of data that you can collect about the system at runtime that's not specific to a particular user, like how fast things are running, how many API queries you have left, for example. And then logs is kind of what you would expect, which is an iLogger interface where you can use traditional logging, and that then gets captured and exported. So the collector takes all of that data and then puts it into somewhere where you can store it long term and then search over it. So this is how open telemetry works. You've got instrumentation capturing all this rich data about your application. You've got a collector, which is a service that runs locally that stores that and caches it. And then you would plug in an exporter, which exports that data to a monitoring system. Um, then on top of that, you would typically have a user interface where you can explore the data and understand what's been going on. So the concepts I've mentioned, first one is traces. The trace has a unit of work called a span. So when you're doing anything with OpenTelemetry, you'll start to be familiar with a span. Uh, I kind of see it as being very similar to a using statement. Like you've got I guess, a context, and everything runs within that context. A span is very similar. So you would initialize a span, and you can have spans within that. Spans can have attributes, so you can store data, any metadata you want inside the span, and it all gets captured in the system. They're typically created by instrumentation libraries, or you can manually make your own. So if you want to create a span based on some custom code or logic in your app, you can do that. Or if you're using one of the instrumentation libraries, it would create the spans for you. Spans are nested. So, like I mentioned, if a user clicks a button, then that makes an API call, for example. The API call itself would be a span, but it belongs to the original call. And spans have kinds. So you can separate like user initiated requests or queries versus things like automated system commands in the back end. We've then got metrics. Metrics are measurements captured at runtime. They're created by meters, and they're typically defined, again, in instrumentation libraries, or you can define them manually via the SDK. So a meter might be CPU usage, for example, as a meter, or amount of RAM available. So those are kind of meters that you could poll or run periodically, or they might be more specific. So you might want to capture the number of users you've got in the system. And that's something you might want to poll and just capture. So, for example, if you're looking at a trace, you might want to look at traces and metrics at the same time. So, for example, if a user reported an issue with slowness or there was a particular crash, then you'd see the span, you'd see the attributes and the exceptions and the errors that happened when the user made that request. But you might also want to see at that time, what were the system data, what were the system metrics. Meters can be aggregate or live as well. And I'll show you both of those types of metrics. You've also got logs, which are essentially an extension of the logging format. They're timestamp text records. You can put structured data in them as well, or you can make them unstructured. The log exporters can plug into existing log infrastructure. And for .NET, that would basically be an iLogger interface. And the app that I've got in our demo shows you what that looks like. So far I've talked about instrumentation libraries. Now with AI applications in particular, I guess there are typically a lot of services that you would be calling, or you would be using libraries to kind of orchestrate those services. So whether that's LLMs, vector stores, different types of search capabilities, like local models, for example. There are lots of different components and services that you have to plug together to build an AI application. So the first one I wanted to call out was probably the simplest one, which is the Azure OpenAI SDK client for .NET. So that has instrumentation for traces. So it would capture your chat completions, for example. If you're using GPT Vision, like it captures that as a span. So it does tracing out of the box. It does some metrics out of the box, but you can really need to kind of configure those yourself. And it has logging out of the box. So it's essentially you can install that SDK, and if you've got OpenTelemetry configured, it will automatically capture the spans for your Azure OpenAI calls. If you're using any other component in Azure, so using the Azure SDK, so in the app I'll show you, we're using document intelligence. So whether it's like a PaaS service or any of the management interfaces for Azure as well, traces and logs are captured automatically. So that comes out of the box with the Azure SDK. The Azure SDK is automatically configured for OpenTelemetry. You can extend it as well if you want to capture any additional data, but it just works out of the box. And then the other one I wanted to call out was semantic kernel for .NET in particular, because they've gone really big on OpenTelemetry and the design for semantic kernel. So it does traces for anything. If you're using semantic kernel as like your orchestration tool for calling and chaining together different AI components. It also comes with metrics, which is super handy for AI in particular. So when you're looking at things like token usage for LLMs, it measures those by default and it exports those as open telemetry metrics, and it also supports logging. So far I've talked about enabling telemetry in your application. But then when it gets to exporters and actually trying to export the data, the one I want to show you for the production environment is Azure Monitor. So Azure Monitor will basically show you an open telemetry span in the UI. You can navigate to see specific attributes. And I'm going to show you a live demo of that in a second. So the UI is built in. It supports open telemetry out of the box. Traces, metrics, and logs are all supported. And if you're using that with log analytics, then you've got long-term storage of data. It's delivered as a service, and you basically just pay for the amount of storage that you're using. It's ideal for production workloads, especially if you're producing large volumes of data, and you can use a single Azure Monitor instance to capture telemetry data from any of the components, libraries, and tools that I've talked about so far. So I'm going to show you a demo from my other machine. It is a RAG application running in Azure Container Apps. It is written in ASP.NET. And this application, you upload documents, like corporate documents about, in this case, we've done things like we've got a fictional company, but we've got like market analysis, we've got our HR documents and policies and stuff like that. And we've uploaded them. It's indexed those documents and put them into AI search. So we can do essentially like a private GPT of those documents, and you can ask it questions and interact with it. So if you wanted to understand what's in our fictional health insurance fund, what things are covered and what things are not covered, you can interact with that like a RAG application. So this is a production app that I've got deployed. It's got a number of components. So I mentioned the container app that's running this ASP.NET service. We've also got things like Azure Functions, which does some of the archiving. We've got the search service component. We've got Azure OpenAI deployed there, which has got our models. So we're using GPT-4 to do the actual like text analysis and generation. This demo is fully open source. There's a link I'll put in the end of the talk. And important thing is that I've plugged this in with OpenTelemetry and captured all the data about what's happening in the application. So I've got application insights running on this app, and when I'm interacting with it, I can look at performance. I can look at the particular traces I've got. Let me just go back to where I was. Excuse me. I can interact with my app. And then in the UI, I can drill into the samples to see everything that happened when I clicked on the button. So for a RAG app, there's the retrieval, which is the search, which goes into AI search. So I can see here I've got my search client call, my call to AI search in the backend with a specific query. I've got the two chat completions for the LLM. So I can see those combined as the specific trace. And then anything else that's kind of captured in the backend that I can see here in the trace. So that's my sort of production app, and I can use this to understand, okay, what's happening end to end in my request, and then I can also look at particular types of calls. So, for example, like this is my LLM call, and I can go back and look in the application to understand all the times I've called the LLM, what the typical response time is, and what's happening with that application. So that's production, but we talked about .NET Aspire. So I'm going to go back to the slides and talk a bit more about what happens in Aspire. So this is a RAG application that I demoed. The idea is that you have a user question. You would look up your specific documents. That's the retrieval component. The results of that using some kind of vector search would be augmented into a chat completion query. And then you'd use an LLM to generate a response back to the user. So I guess what makes this unique when it comes to observability is that you've got one user request. And as far as the user sees it, they've typed in a question, they get an answer. But in the back end, you're basically stringing together all these different services and different components. And you want to see that as a single span, like I showed you in that demo just there. So as an example, there's a whole bunch of different technologies that you could be using to combine together to make a RAG app. This particular one is using Blazor, Azure AI Search, GPT-4, and semantic kernel. But you could be using any number of combinations of different technologies in the front end, the retrieval mechanism, and the LLM. You could also be using a small language model if you're running things within a private environment, or you've kind of what I've categorized just like the glue kind of libraries, so for specific metrics. When it comes to observability, the things that I think are really important to measure is on the front end. There would be things that you would typically want to observe anyway, which is who is the user. So if a particular person told you there was a problem, like how do you capture who that was and when it happened? When it comes to retrieval, then you're really looking at performance is one major thing. So especially with AI and LLMs, like the retrieval time and the reliability of the response are things that you want to measure and capture. So I would suggest doing those as metrics and capturing the API parameters as span attributes, which you would get out of the box. If you're using an orchestration library, then capturing the chain or the flow and then trying to emit that as a span, again, is really important. So as an example, when it comes to traces, metrics, and logs with AI applications, the traces, I'd say you'd want to capture retrieval calls, so the actual search queries, the API calls to other components, document and search lookups, and also authentication. So those are traces you want to capture. In terms of metrics, tokens is a massive aspect of this because with GPT or your measurements basically for how you use GPT is the number of tokens that you're consuming. You also have rate limits on the number of tokens per minute that you have, and the amount that you've got allocated in the system. So you want to capture those as metrics. And then with logs, I think in particular user query, but also looking at safety violations, the response from the LLM, and anything else you might need for auditing as well. So those are kind of key things that I think is important to capture. Okay, so now I'm going to switch back to my demo environment, and I'm going to show you a couple of other things. So in my application, the first demo I did was using application insights. And the way I did that was to, in my service builder, this is my ASP.NET application. I'd install the application insights package, which is the Azure Monitor OpenTelemetry exporter from NuGet. And if I've got an application insights connection string in my environment variables, then I'm going to configure application insights telemetry. That out of the box sets up traces and logging. And the only thing that was missing, I think, in that configuration was metrics. And I mentioned earlier that semantic kernel emits a whole bunch of really helpful metrics as well. So I wanted to enable those and just measure in particular like token usage and things like that for OpenAI. That's my production configuration. So if I'm running a dev environment, you could emit to application insights. You get all the capabilities and stuff like that. But if you've got multiple developers working on the same project at the same time, it's going to get a bit confusing as to whose environment is which. There's also not really a simple way of just like resetting all the telemetry data. So if you're just kind of mucking around or experimenting with stuff, really you want an environment that's more sort of like temporary that you can just use to visualize. So what I've done in this application is I've said, okay, in .NET, if this is in development mode, so if you've run .NET Run locally, it would by default be development. Or if you set the environment to be the development environment, then I'm going to configure some extra stuff. So I want to enable OpenTelemetry logging, capture all of my logs. I want to capture all of my metrics for semantic kernel, anything in Azure. And then also I want to enable all traces, so capture all information from semantic kernel, from the Azure SDK, and also from the Microsoft machine learning libraries. I then got ASP.NET Core instrumentation, which you get with the OpenTelemetry instrumentation for ASP.NET Core. That's a package that you install. And then I've also installed one for HTTP. So when I've got all of that running, I can run my app locally. And I've also got running the .NET Aspire dashboard. You can run this if you're using it through Visual Studio. My preference is actually to run it directly in Docker. So if you've got Docker installed locally, whether that's on Windows with WSL, on Mac OS, or any other environment, then you can do Docker run with the Aspire dashboard. There's the link there. There's details on how to do that in the Aspire documentation. But that basically runs the Docker image, the Docker container, and then we've got this Aspire dashboard running locally on our machine. That is like a monitoring environment designed for OpenTelemetry, where everything I've now got in my app that's running, all my traces, my logs, and my metrics are there, and they're up and running. Hopefully the app's up and running now. So I've got that RAG app I demoed earlier running on my local machine, and I can capture the same information that I was looking at in the production application. But I've set up ASP.NET. Instead of sending it to application insights, it's sending it here. So like if I come into here, I can see what's happening in my app, which calls are being made, what backend calls are happening in my application. And I've then got my end-to-end traces as well. So this one's running at the moment. That's running the OpenAI call. Let's have a look at that. So the same information that I saw earlier in application insights is available on this local Docker image that's running the .NET Aspire dashboard. Locally on my machine, I can see all my backend calls. I can see the OpenAI calls, the chat completions, all the attributes, the configurations, everything like that is available just locally on my machine. And I can capture and play around with my application. I can try and crash it because I'm a developer. And I can also flip to the specific metrics I have available, which I mentioned earlier. Semantic kernel has this really helpful automated metrics for completions and token usage. So it will capture OpenAI tokens used, tokens remaining, and give you that as a graph as well. So I'm just going to go back to my slides. Okay, so to recap, OpenTelemetry is a plugin solution. It's designed so that you pick and choose which instrumentation libraries you want to use and which ones apply to the specific technologies that you've got in your back end and your front end, and you string those together. I think typically when people talk about open telemetry, they talk about monitoring in big production environments. But what I really like about the .NET Spy dashboard is that you can use the same technology to instrument an application when you're doing development. And often when you're doing development, especially in AI applications, not everything is running on your local machine. So like the LLM itself is a service that I'm consuming. The AI search component is a service that I'm consuming. But I still want to do that debugging of my local web app. And I can use something like this to kind of capture that whole end-to-end environment and that whole end-to-end trace. There's some extra resources that I wanted to highlight. So this RAG application is a project on GitHub that you can look at. And if you want to, that one comes with application insights out of the box. And using that link, you'll also see how you can use it with local telemetry as well with the Aspire dashboard. There's a great session on observability, .NET 8 and OpenTelemetry. And there's a blog post from the semantic kernel team about what they do with telemetry, which again is using and heavily invested in OpenTelemetry, how they capture spans, metrics, and stuff like that in semantic kernel. And then lastly, there's a collection available for everything that's in the sessions today. Thank you for coming to .NET Conf, and good luck with your observability adventures. Thank you very much.